Hello students, today we are going to see some more interesting and important questions from MS Chouhan sir's Organic Chemistry, Aldehydes and Ketones level 1 and the question from 11 to 20. Come on, let us discuss these questions. The first question, actually as we observe this compound, it is actually alkyne compound. What do we call this? Is alkyne. Alkyne converted to what it is. Under the reaction, it's going under the reaction of HgSO4 with the dilute H2SO4, right? So it is actually a conversion reaction. So this alkyne compound, which is converted to a compound, what is that compound they are asking? Actually, HgSO4 and H2SO4, it's basically Kucherov's reaction, HgSO4 with dilute H2SO4. So what is the name of the reaction? It is called Kucherov's reaction. Kucherov's reaction. Right. Now, Kucherov's reaction. So, what is the speciality of Kucherov's reaction? Alkyne, which is converted to carbonyl compound. Carbonyl compound. That is only the speciality. So, if you want to convert that alkyne triple bond converted to carbonyl compound, you can go to Kucherov's reaction. Right. Come on. Now, how do we identify the answer with this? Right. Now, here, as we observe this point, pH is there, no? pH, C triple bond C, PHOCH3. This is what it has mentioned in that compound, and which is undergoing the reaction with the HgSO4 along with what it is? Dilute H2SO4 hydrolysis also along with that generally. Right now, what do we observe? This HgSO4, which is going to break the triple bond. So what happened? You will get pH, that is phenyl, and C double bond C, here pH, OCH3. Right. Now, the next point, what happened? Here, both the side bond breaks. Now, here you will get Hg. This Hg plus and this is minus. Now, this is undergoing the reaction of hydrolysis, that is dilute H2SO4 along with it. So, what happened? This H2O, this lone pair of electrons are there, no? This lone pair of electron, which is going to attack the minus charge, here plus charge, no, this minus charge which is going to attack, that is HOH, right? So that means here you will get the point of here pH, C double bond C, here OH, here you will get what it is, OH, and here pH OCH3. So this is this lone pair of electrons which is going to attack only that minus charge point. So now what's going to happen here? Due to that resonance, here resonance takes place. So due to that resonance, what happened? Transferring of electron. So this electrons which is going to transfer over here. So then this which is going to transfer. So you will get the point of pH, CH2, C double bond O, here pH, OCH3. That means what is the exact point according to that option? Here benzene molecule which is connected with CH2, C double bond O, here benzene molecule which is connected with anisole OCH3. Right. So this is the product you will get. So this only will be appear. The correct option will appear like this only. I hope you got that idea. How do we get that this compound through Kucherov's reaction? Kucherov's reaction. So Kucherov's reaction, what is the ingredient? HgSO4 along with dilute H2SO4. I hope you got that clarity. How do we get this answer? Through this compound, right? So Kucherov's reaction, it is nothing. Please remember alkyne which is converted to carbonyl compound. Hope you got the clarity. So which is the correct option? pH, CH2, C double bond O, OCH3. Now which is the correct option? This is not the correct option. Okay, so this is not the correct option. Okay, this OH will not be coming, and this also it's not. Carbonyl compound only I just mentioned. So carbonyl compound, which is the correct option? C double bond O comes attached over here or here. So actually, as I mentioned, that answer option. So option C is the correct option. I hope you got the clarity, and even you check the answer where that C double bond O which is attached. See here. So this is the correct option. Option C is the correct option. Okay, come on, let's go to the next question. And one more point I wanted to mention in this point, here COH double bond. So actually this point, you will get the tautomerism. Here C double bond O, here OH, acidic hydrogen. So here you will get the tautomerization. Tautomerization. Right. So this is the point. That is what COH, which is converted to C double bond O. So that point is another one more important point. You can identify this is Kucherov's reaction. Okay. As we observe this is like a ester formation. See here actually a triangle, that is cyclopropane, which is connected with the C double bond O OMe and the same way C double bond O OMe. So this is ester which is undergoing for hydrolysis. What is the product? So ester RCOOR, right? So here R C double bond OOR. which is undergoing with that hydrolysis H2O. So you will get R, C double bond O, OH, carboxylic acid, and ROH, alcohol, you will be getting, right? Now, in that way, when we consider this point, here, this is actually what it is. C double bond O, here also C double bond O. So the bond breaks over here. So the bond breaks over here. So you will get HOH, right? HOH. So you will get OH over here and H, and the same way here OH, H, two water molecules. So you will get COOH, COOH. So that means carboxylic acid and alcohol you will be getting. But still, there is a reaction to find this formation, right? So in that point, here actually a triangle, that is, what is the triangle over here means a cyclopropane, right? Cyclopropane, which is connected with C double bond O, C double bond O, again which is connected with oxygen, and then this side Me and this side Me. This is what we observed in that question. Now this is undergoing with that hydrolysis H2O, right, water molecules. So what happened here? HOH. So the bond breaks, two molecules of water molecules. So here bond breaks. So here OH and here also OH and here H and here H. So you will get that triangle. That is, what is a triangle called? Cyclopropane. So this cyclopropane, which is connected with two molecules of what it is? Carboxylic acid, COOH, and then this side COOH, right? So then MEOH is another one. MEOH, that is ROH. So MEOH, right? Now in this point, which is again undergoing for hydrolysis, that we have to check for this compound, right? This point only. So here in this point, here this triangle, that is cyclopropane, again it undergoes with that hydrolysis COOH, here COOH. Right now, undergoing with that hydrolysis H2O, this lone pair of electron, which is going to attack this point. Right, when it is going to attack, the bond breaks over here. So what happened? The bond breaks like this. This side COOH, and then this side what it is? COOH. In this point, here you will get the protonated alcohol. O here hydrogen and here also hydrogen. This HOH, no? So you will get the protonated alcohol. So protonated alcohol, you will get plus charge over here. You will get that minus charge. So what happened? This protonated alcohol, again, it breaks that bond, and actually water releases takes place. H2O. So this H, which is connected with this OH, you will get that water releases. So again, this plus charge, which is going to connect over here. So here, what is the product you are getting? That is intermediate product only. But how it is possible for intermediate? So here in this point, here you will get what it is. Here OH you will be getting on the top, here OH, because hydrogen it just releases, right? So OH, and then here this side what it is? COOH, and then this side C double bond O, right? This OH and C double bond O. Now again, this minus charge is there, no? So this minus charge, which is going to, again, it is going to attach over here. So when it is attaching this point, so you will get 5-membered ring. How is it possible? 5-membered ring. This is 1, and this is 2, and this is 3, and this is 4, and this is 5. So 5-membered ring. So you will get that point of what it is here. Here actually what it is, 5-membered ring, like this you will get, right? So you will get like this. Here O, which is going to attach over here, and then here C is there, no? C double bond O. Here the same COOH will be there, COOH. This COOH is same as it is this COOH, only one, two COOH is there, no? So one COOH only, it releases water molecule. The other one, it stays as it is. So you will get that 5-membered ring. So just to the upside down, if we are writing like this, right? Okay, if we are writing like this means, so one side what it is? COOH, the other side double bond O, here ester, you will get this compound. I hope you got the clarity. How do we get it? See, generally this is based on ester formation. Ester, how do we go undergoing for hydrolysis? That is only the main point. If you know the concept, easily you can identify the answer. I hope you got the clarity now. Which is the correct option according to this? Here in this option, it is 6-membered ring. This will not be the correct option. And option, no, this will not be the correct option. Option B, C double bond OH, COOH, yes. And where that oxygen has gone, so this will not be the correct answer. And COOH, yes, it is there. C double bond O, yes, it is there. And option C is the correct option. And see, here COOH is there, but where it is attached? Actually, triangle, which is comes over here, both the side, which is connected with COOH, and then the side COOH. So this only it has to be like that. Means in that side, one side is COOH, the other side keto group, which is attached with CO. That means ester. So the option C is the correct option. As we have observed, this is the proof for you to understand this question, right? Got it? Okay, come on, let's go to the next question. I hope you got the clarity to find the answer in this. Okay, come on, let's go to the next question. Group is their OH group, which is giving the product of 2-hydroxyl along with that C double bond O keto group. Now the conversion can be achieved. See, Me to CO. So this is actually keto group, Me to CO, right? Me C double bond O Me. So this is keto group, and H3O plus hydrolysis, that is acid hydrolysis, KMNO4, it is oxidation process, and OH minus, this all these actually would combined reaction. It is one upon the other combined reaction. What is the product? So this is the product we are getting. So which are the reactant when we are going to give for this to get this product? So that is the question. Okay, come on, let us check with this. So here Me, here also Me combined together C double bond O. So now in this point here, which is going to react with this trihydric alcohol, right? So here I just draw in this way so that it will be easy for us to understand. So here what it is, OH, right? Here also OH, right? So this is the way they have given. Also here also OH, trihydric alcohols, that is what both combined together. Yes. Now what happened? This oxygen, right? This oxygen which is connected with the H. So you will get what it is, water molecule, releases water molecules, right? So you will get that cyclic compound. So how you will get that? Me, and this side also Me, these connected with the C double bond. So this double bond which is deviated, the side O and the side O. Why? Because the side O is there, no, and the side O is there, no. So both it is interconnected. And here what happened? So you will get attached with it, what it is. So you will get attached with that, like this only it is attaches, right? Here OH, you got like this, right? Okay, now here KMNO4, second one KMNO4. Why KMNO4 we are going? No, oxidation process to convert this OH will be converted to what it is, keto group. Alcoholic group generally when we go for high, what it is, oxidation, KMNO4 oxidation, you will get keto group. That is the reason. So the second point, what it is, so this is the first point, methyl ketone, dimethyl ketone, that is actually CH3 C double bond O CH3. So that is what it is. Me2CO it has mentioned. No, that is. So this is the first one, and this is the second one. So what is the product you will get? It's this point will check it. This point will convert it to C double bond O. So the same way, Me. This point will not attack all these. Only it will attack what it is, OH, which is converted to keto group. So Me, and the side also C double bond O. No, so this is deviated here O and here O, and which is here connected with that. Right. So this is right. So C double bond O, right? So this is the product. Now again it goes for acid hydrolysis, H3O plus. So H3O plus, it is acid hydrolysis. So H3O plus acid hydrolysis, first and foremost the bond breaks over here. So Me, C double bond O, Me, right? So keto group you are receiving. After that what happened? This acid hydrolysis, the bond breaks over here, this side, both the side. So you will get what it is, HOH. So here HOH, right? So this is C double bond O. So water molecules, this point again it releases water molecules. So this O which is connected over here, that is what keto group. Now remaining what it is, OH which is directly which is attached to that compound. So here the compound which is received over here, yeah, both the two products now. So this side, one product this side, the other product is this side, right? I just draw this here, C double bond O, right? C double bond O which is connected there only. So C double bond O, and here OH, and then this side here also OH. I hope you got the clarity. Now I just draw in a straight way. So this side here OH, and here also OH, and then here double bond O. So you will receive this product. That is what they mentioned. This product. I hope you got the clarity. How do we get? So what are the main points, ingredients we are adding? First thing we are adding what it is, Me2O, that is methyl dimethyl ketone, such as acetone, right? CH3CO CH3. Then second one KMNO4, and third one acid hydrolysis. Acid hydrolysis we are receiving again that methyl ketone, and second one this HOH. No, so this point only it is breaking HOH. So this HOH hydrogen and this OH combined together, water releases. So it releases water, and remaining one O which is connected with carbon. So you will get dimethyl ketone, right? Here you are getting, right? So then remaining thing OH is there. No, so that is the side you are getting this product. So this product only I just draw like this. So which is the correct option? Option A, B, C, D. Let us check which is A, B, C, D. So this only is that product already we received. But what is that idea? So first thing Me2O. Me2CO, that is dimethyl ketone. That is, in the second one what it is, KMNO4 and H3O plus. So this is only, so option B is the correct option. Option B is the correct option. So B is the correct option. These are all we are not using. This point and all we are not using. Only this point, option B only we are using, right? I hope you got the clarity. How do we get it? Come on, let's go to the next question. B can be differentiated by 2,4-DNP, filling solution, glucose reagent, and NaHSO3. Okay, now this is actually ether group, ROR, right? ROR, it's a ether group. Ether group during that what it is, H3 acid hydrolysis, what are the products we are getting? Okay, before finding the product, I would like to mention each and every options. So here option A, here what it is, 2,4-DNP. So DNP actually dinitrophenyl hydrazine, right? So 2,4-DNP it is used for to find out that what it is, aldehydes and ketones. So to detect aldehydes and ketones. So 2 for DNP we are using for that purpose. Right now, so second one, what it is? Filling solution. Filling solution, second one here, filling solution. Filling solution we are using for what purpose, do you know? So this is we are using actually to find out that this to differentiate the aldehydes, differentiate aldehydes. Aldehydes. Why, you know? Because filling solution can detect only that aldehyde. It will not detect that ketone. So it is used to find out that aldehydes only. So it is to detect aldehydes. And next one, what it is? Lucas reagent. Lucas reagent, you know very well. This is to detect what it is. Primary, secondary, tertiary alcohol. What is that? Concentrated HCl and dry ZnCl2. Right. So concentrated HCl and a dry ZnCl2 zinc chloride. So this is primary, secondary, tertiary alcohol. To detect that purpose, we are using Lucas reagent. And the next one, what it is? The last one, what it is? Sodium bisulfite. So this is we are using for what purpose? Do you know? So this is we are using for to purify aldehydes and ketones. To purify aldehydes and ketones. Right. So these are the 4 points we are going to see to that. Now here in this point here, they mentioned the compound. I just draw the structure for you to understand here like this, right? O, and then again it is like this. So here double bond, and here also double bond. So this is acid hydrolysis, H3O plus. So what is the product you will be receiving? You know, so the bond breaks over here. So the bond breaks over here means here H, here OH you will be getting. So that means here like this you will get the product. Right, here OH, now OH, this double bond over here, right? And then here what it is? This side here OH, like this only. No, so the same here OH is there, no, and then here OH. Actually these are the two main products. So this is actually tautomerization takes place. So this point actually what it is here, CH3, here this point which is going to attach this hydrogen which is going to attach over here. So that means CH3. So here CH3 and then here CH3, both combined together, C double bond O. So this is ketoenol tautomerism. So this point which is going for ketoenol tautomerism, and CHO, like, so this is tautomerization. So aldehydes and ketones. So here filling solution only we are using. In this point we are using what it is? Filling solution. Filling solution, whether ketone is available or aldehyde it is available. So in that way to check, here we are using what it is? Filling solution. I hope you got the clarity. 2 for DNP to detect aldehydes and ketones, right? And here filling solution to differentiate aldehydes and ketones, whether it is aldehyde or ketone, to identify filling solution we are using. And next one, ZnCl2, it is Lucas reagent we are using for what purpose? Primary, secondary, tertiary alcohol to differentiate. And sodium bisulfite, it is purify aldehydes and ketones. Any what it is defects are there means we can identify that. Those points we to identify sodium bisulfite we are using. So which is the correct option? Option B is the correct option to differentiate aldehydes and ketones. So this is the product. You know what is the product you received? I hope you got the clarity. This point and this point only. This is A and this is B. So B and A, it is like tautomerization way we can identify. Right? Hope you got the clarity. So aldehyde and ketone, to differentiate, to find, to detect that aldehyde. For that purpose only we are using filling solution. Hope you got the clarity. Come on, let's go to the next question. Methyl format you're getting. Now you have to identify the product A, how that structural formula. Okay, now first and foremost, try methyl format. I just to draw the structure for you to understand. Here hydrogen which is connected with carbon, here OMe, and then this side OMe, and then again OMe. So this is trimethyl format. So this trimethyl format reacts with what it is? Hydrolysis. So here, so HOH, right? So this HOH, the bond breaks over here, both three side also. So here you will get H, here OH. Same way HOH, and then here HOH. So you will get what it is? MEOH you will get. So MEOH, it is methyl alcohol. So 3 molecules of methyl alcohol you'll be getting. And then here HC, here OH. Here also OH. And then here also OH. So 3 OH. So here in that water release is taking place. So water release is HOH you'll be getting. Then remaining product, what it is? Water releases takes place means here H2O. It is there, no? That means HC, here O, and then this bonds comes over here, no? So C double bond O, and then here OH. So what is this? C double bond O. This is formic acid, HCOOH. It is a formic acid. That is what trimethyl format it has mentioned, right? Okay, now this methyl alcohol which is going to react with this component, which component it is going to react? This component which is going to react. Come on, let us check how this is going to react. So this MEOH combined with this component, right? Okay, so this component here and this point, right? C double bond O, here O, right? So this is the way it's, so this lone pair of electrons which is going to attack this carbon, right? So naturally this transverse of electron takes place. When the transverse of electron takes place means here you will get both the side what it is O here, right? Now here OH, here OMe you will be getting, right? Here OMe, right? Double bond is there, no? One side OH, here OMe, already O is there, no? So now here again it undergoes with that H plus ion. So acid, okay, undergoing with that acid point. So you will get the answer over here. This H plus ion which is going to attach over here. So you will get protonated alcohol formation. So here what you will get it, you will get like this, right? So here OH2, here OMe, right? So this is releasing. So you will get that carbocation formation. So what happened? Water releases H2O, water releases. So you will get what it is? Carbocation formation, this point here, right? So in this OMe and then here plus carbocation formation. Now in this carbocation formation which is going to react here again, it's going to react with what it is? Methyl alcohol, MEOH. MEOH which is going to react. So this MEOH, this is a minus charge is there. No, this minus charge which is going to attack this plus charge. So what happened? Both the side you will be getting what it is, the side O and then here OMe and then this side OMe and this side also OMe. So you will get this kind of product. Which kind of product? This product you will be getting. Hope you got the clarity. How do we get it? So this MEOH which is going to react this compound. So you will get the protonated alcohol compound. Again it releases the water. So carbocation formation takes place. Again MEOH, because 3 molecules are available, right? So 3 molecules. So you will be getting this product. Hope you got the clarity. How do we get this compound? Now which is the correct option? OMe 2 sides. Okay, so that means compound A, compound B, compound C, and D. So compound A, OH is there, compound B, OMe, oh yeah, compound B, and compound C, no, compound D also. So option B is the correct option. Hope you got the clarity. How do we get this? See, this is a concept-based question, how it is reacting. So if you know a number of reactions examples, you will be thorough with that correct option and answers too, right? Come on, let's go to the next question. The question, as we observe, this is keto group. We are getting the product PQR, and finally we are receiving alpha beta unsaturated compound. How do we get it? This is alpha and beta. So this C double bond, this is alpha and this is beta unsaturated compound, right? Alpha and beta unsaturated compound. So this is aldol. Okay, aldol compound, right? Can we observe in that way? Right, come on. Now, in that, which is the reagent to carry out this conversion, PQR? Usually, we are going to check with that mainly Walker's process. What do you mean by Walker's process? I will tell that speciality of Walker's process. Walker's process. Okay, so you know what is the speciality of Walker's process? Alkene double bond, which is converted to what it is? Keto group, that is carbonyl group. Carbonyl group. So that is the speciality. Walker's process is nothing. Alkene which is converted to carbonyl compound only. What do we call? It is a Walker's process. So through this observation, let us check with that answer. Okay, now here as we observe CH2 double bond CH2Br. This is actually allyl bromide. What do we call? This is allyl bromide. Okay, so allyl bromide which is reacts with all this OH minus and heating all this here also OH minus Walker's process. So let us check with these observation. What is it? Now Walker's process, everywhere Walker's process is there. What is the main idea for Walker's process? Walker's process is nothing. Alkene converted to carbonyl compound. That is only the main point to mention over here. That is a concept way. Now let us check this PQR, that complete idea. So as we observe this compound, so here let me give you that idea. So here this compound double bond O, no, so this one here C double bond O, this is connected with what it is? OH minus. So here OH minus is there, no, so this OH minus which is going to here actually 2 hydrogen CH2, right? CH2 everywhere it is cyclo compound only, no, so here only double bond, then other than that everything CH2. So this OH which is going to attack over here to relieve that water molecules. So what you will receive? So you will receive that here double bond O, here you will get the double bond O, here one hydrogen will be there, here one minus charge. Why? Because it releases water molecules, so you will get that minus charge over here. So this minus charge is waiting to receive. So what it is waiting to? Allyl bromide here, allyl bromide, no. So what is it? Allyl bromide, CH2 double bond CH single bond CH2 Br, it is there. So this actually this minus charge which is going to attack this carbon, this minus charge which is going to attack this carbon. Why? Because this is minus and this is plus, right? So this minus charge which is going to attack. So what's happening over here? You will receive the product which is connected with it. So here HBr, it just releases, no? So this H and then this Br, so it releases that HBr, and you are getting what it is. You will get the compound of here C double bond O, no? Here double bond O. Here what you will get it? CH2 double bond CH. Here what you will get it? CH3. You will get this compound only, right? CH2 double bond CH, CH3. Right now in this point, actually Walker's process is taking place. So this double bond is there, no? So Walker's process. Walker's process. What do you mean by Walker's process? Alkene which is converted to carbonyl compound. So this bond which is breaking, so you will get this compound. What is the compound? So here you will get double bond O, here CH2, C double bond O, here CH3. You will get this compound. Why? Because double bond, that is alkene which is converted to carbonyl compound. That is only Walker's process work. Right now we got the carbonyl compound. Now another one more OH minus which is going to react. Why? Because to get the product OH minus base which is going to react. Why base is going to react? To release the water molecules H2O. So this base which is going to react. So here what happened? And this point C H2H. I just deviated CH3 in this way. Now what happened? This oxygen which is connected with this hydrogen, right? So you will get water molecule releases. So the bond attaches over here. So you will get what is that kind of formation? So you will get this C double bond O, here CH2, here C double bond O, and then here CH. Why CH? You know this CH, and then this which is connected over here directly. Now this bond, double bond is there. No, one more attaches over here. So you will get 1, 2, 3, 4, 5 membered ring. You will get it. So what is it? 5 membered ring like this. You will get it. See, double bond is there. No, so here you will get like this, like hexagon, cyclohexagon, like this. Here C double bond O. Here you will get what it is. C double bond O. In this point, you will get double bond, right? This point only I just mentioned here. Okay, hope you got the clarity. So this is a functional group which is attached with that double bond. So here in this point, alpha beta unsaturated carbonyl compound you will receive. Okay, so here where do you get that alpha beta unsaturated? This is alpha and this is beta unsaturated. Now, what are the main points and ingredients we are checking over here? First and foremost, Walker's process, alkene converted to carbonyl compound. So that is CH2 double bond CH, CH2Br. And the next one, what we observe here, OH minus. So here OH minus Walker's process, and here we have observed OH minus. And here again, what is it? Here we are heating. So to release the water from here, we are releasing. So this is heating process. So you will get that finally this compound. Hope you got the clarity about how do we get this compound. The compound they have given, product they have given. Only thing we have to find out the reagent. What is the reagent? So first and foremost, this is OH minus. The same idea, both OH minus and here heating process. The same way here CH2. Where do we use that Walker's process? That is very important. So Walker's process. This is actually Walker's process OH minus heating process, and Walker's process CH2OH. Both are alike, right? And heating process starting only they are using. So option B is the correct option. Why? You know, this is alkyl bromide and OH minus. That is the way we observed, right, in this question. And the next one, OH minus and heating process. This is complete Walker's process. We just mentioned option B. Right. Now, this is Walker's process, OH minus and heating process, everything observed in that B option. Hope you got the clarity. Now, you got that idea about that concept of Walker's process is what? Alkene converted to carbonyl compound. The first question also we observed what it is, Kucherov's process. Kucherov's process also you know very well. What is it, Kucherov's process? HgSO4 and dilute H2SO4. First question. So, how do we observe? What is the point we have got that in that question? So, in that question here actually, see here in this point, alkyne converted to carbonyl compound. Here alkene converted to carbonyl compound. I think both you got that idea. Kucherov's process and Walker's process. Walker's process, alkene converted to carbonyl compound, and Kucherov's process, it is, see, I just mentioned very clearly because these are all concept based. It will be helpful. Walker's process and Kucherov's process. Kucherov's process. Okay, so this is actually what it is, alkene, and this is actually alkyne. So alkyne and alkene combined together, carbonyl compound. That is the main. So Walker's process actually alkene converted to carbonyl compound. Right now here Kucherov's process convert alkyne converted to carbonyl compound. This is alkene converted to carbonyl compound. I hope you got the complete idea about Walker's process and Kucherov's process. And ingredients: alkene, it is allyl bromide. Kucherov's, it is alkyne, that is C triple bond C, which is converted to C double bond O carbonyl compound. Hope you got the clarity. Come on, let's go to the next question. Here, the next question above is Bayes-Villiger rearrangement of an asymmetric ketone with magnesium monoperoxyphthalate hydroxylate in the drawing Mg2 plus is omitted for clarity. Right now, identify the major product. See, generally, here in this point, Bayer-Villiger's reaction used for what purpose? You know, it is used for ketone oxidation. Ketone oxidation. That is the main process we are using. What it is? Bayes-Villiger reaction. So, Bayer-Villiger, that is, see, concept and all, it will be easy to remember, right? Villiger's rearrangement or reaction used for to change that, what it is, ketone oxidation process. Ketone oxidation process. Repeatedly, as if I say no, it will be easy for you to remember. Okay, now for example, here I just give that example because this is also big. It is so C double bond O CH3. Right now here Bayes-Villiger's reaction, Bayes-Villiger's reaction, so you will get, what is it now, CH3 C double bond O, here C, here Me thrice. So this is the product you will get. So this is per acid group. So here in this Bayer-Villiger's reaction, it is per acid. Right now in this, so migration will be tertiary, secondary, and primary. These are all concept oriented. Now I'm coming to that main point. Here what it is, OR, C double bond OOR, and here peroxyphthalate, COOH, that is minus C double bond OOH. So this is per acid, CO. Three O's are there, you see. So that is per acids. Okay, now which is converted to here a simple way, I'll tell you. So here actually the bond breaks. So the bond breaks over here. So you will get that per acid. You will get here 6-membered ring. No, one carbon group which is added. So you will get 7-membered ring. 7-membered ring, right? So 7-membered ring means easily you can identify which is the answer. Okay, come on, I'll explain you detailed way. So here with this compound ROR, right? So here C double bond O, here R, and here per oxyphthalate, right? So here in this COO minus, right? So here these are all concept way we can identify instead of by hearting. Concept only, if you should understand that C double bond O, here OOH per acid. So you will get what it is, that bond breaks over here. So you will get what it is in that one more carbon which is going to attach over here. So in that one more carbon, if it is attaches, means 6-member plus 1 7-membered ring. That's all. You please remember in that way. So the simple way, C double bond O, here what it is, like this, and then here 7-membered ring. So here double bond O, and then next one here O, right? Here O peroxo, and here you will get R. So this R, which is going to attach over here, peroxo, right? Okay, now which is the point I wanted to mention here. So Bayes-Villiger's reaction comes only. You please remember one carbon will be extra added. Right now, 7-membered ring, which is that option B, is that 7-membered ring. So this is the way we can identify easily. See, these are all we can follow the tricks to identify. So mechanism comes, I will tell you that time, right? Come on, let's go to the next question. So which is the correct option? Option B is the correct option. And Bayes-Villiger rearrangement, it is what it is, increasing one carbon extra to get that. And number of rings will be so 7-membered ring you will get, right? 6-membered ring converted to 7-membered ring, right? Come on, let's go to the next question. The next question here, as we observe these two compounds, above compounds can be differentiated by following reagent. Here 2,4-DNP Brady's reagent and Lucas reagent, Tollens reagent, and sodium bisulfite. The same question, actually same concept, which is repeated in that another question also in this video. See, in that Tollens reagents and Felling solution, that is something different. So Tollens reagent and Felling solution, that is to differentiate aldehydes and ketones. Here also Tollens reagents will be answerable for aldehydes. This will be answerable for aldehyde CHO, it will be answerable, but R C double bond O R, it will not be answerable, right? So that means ketone, it will not be answerable. Aldehydes, it will be answerable. So that means to differentiate, the Tollens reagent used to differentiate aldehydes and ketones, whereas here 2,4-DNP Brady's reagent, it is actually used to detect aldehydes and ketones, whether aldehydes or ketones, to detect. And the next one here, what it is, Lucas reagent to differentiate alcohols, primary, secondary, tertiary alcohols, to differentiate. And the Tollens reagent, just now I mentioned, and the sodium bisulfite, that is to purify aldehydes and ketones, right? I hope you got the clarity. Tollens reagent used to differentiate aldehydes and ketones. Aldehyde, it will be answerable, ketone will not be answerable. So that is for what purpose we are using. So this is actually aldehydes and ketones. Now in that point, or this is Acetal, hemiacetal. See, acetal, this is actually acetal. Acetal, how do we identify acetal? OCH3 it is there. And this is hemiacetal, this OCH3, it's not there. So this is hemiacetal. Hemiacetal. Right. Now, in that point here, see, actually, when this point which is going to attach over here, I just mentioned here in this point, hemiacetal and acetal already OCH3 it is there. Here O hydrogen which is replaced. See here OH, and here as you observe here, this is ketoenol tautomerism. C double bond O, here C OH. Right now in that point, aldehyde it is available. C double bond OH, it is aldehyde it is available. So in that aldehyde, actually how do we identify? It is silver nitrate along with ammonium hydroxide. So this is aldehyde is present, that is identified through tolerance, but tolerance reagent will not detect what it is keto group. So to differentiate aldehydes and ketones only, we can go for this purpose, right? I hope you got the clarity. So this is a aldehyde purpose we are checking right now. Come on, let's go to the next question. Really, it is interesting. Why? Because it is like a puzzle, like a compound A connected with PCC, pyridinium chlorochromate excess. So you will get the product of what it is A. So this is a reactant, you will get the product A, and then equivalent of CH2OH, CH2OH, you will get product B, and the Grignard reagent along with hydrolysis, you will get what it is product C, and then sodium borohydride, that is you will get the product D. Now we have to identify the product D, like puzzles you have to identify. Right, come on, let us check. See, pyridinium chlorochromate, what purpose we are using? Alcohol converted to aldehyde. Now in that primary alcohol only converted to aldehyde, for that purpose we are using. Please remember, so what purpose we are using pyridinium chlorochromate? For primary alcohol. So which is the primary alcohol? So this point only is the primary alcohol. So this point only it is converted to aldehyde. So here I just to bring it that idea for you to remember. So this point only which is converted to aldehyde. So I just to draw the structure for you to identify. So easy, these are all easy, simple way. If you know the concept, this OH will be same remaining. But here only you will get what it is. Here CH, here what it is O. That means CHO. So you will get that product here C, what it is, a double bond O, here H, right? So this is the product A. Now product A combined with this point. So here I just rub this point so that you'll get that what is it, that product name. So here you will get this one. So this point I just draw here. So as we write this point CH, and here C double bond OH, right? So now I just put this way. Now this OH, this two hydrogen which is connected with this oxygen. So you will get what it is, H2O releases water, right? So what do we observe this product? So you will get that inverted here OH, and then this side C, and here one O, here one O. Why? Because this just I just put inverted, so you will get like this, right? You got it. Now OH, I just put it like this way, see, right, this way, OH, OH. So this two hydrogen which is joined with that oxygen, so you will get that water releases, so you will get this compound. So this is that compound B. I hope you got that clarity. Compound A and compound B. Now compound C, you have to get it. For that I just draw the structure for you to find that compound C. So this is compound B. Or how do we identify compound B? I just draw that structure. See here, this is that compound B. So this is OH, OH, and then here C, here O, and then here O, both connected with this. Okay, now here Grignard reagent. So Grignard reagent which is going to react. So that means where it will go and attack this Grignard reagent CH3. So this is plus and this is minus. Now that means where it will go and attack over here, this point Mg CH3 minus, right? So CH3 minus which is going to attack that. So this minus charge which is going to attack this point where there is OH minus. So this point which is going to attack. So when it is going to attack, you will get that compound C, right? So how you will get that structure, you know, I just draw that structure for you to understand. So here, this is the way you will get that structure of compound C. So here C, here O, here also O, it will be like that. But whereas over here CH3, because CH3, and here OMGI, right? So not reagent, right? So OMGI, this is minus and this is plus, right? So in that way, so CH3. Now this is hydrolysis taking place, because Grignard reagent means hydrolysis, it's common. So hydrolysis, that to what it is, acid hydrolysis, H3O plus. So what you will get it, get that compound. See, you know how that compound C will be like this, because acid hydrolysis removes that. Here you will get OH, here CH3, and even this point also it will convert it to alcohol carbon which is connected with OH, and here also connected with OH, and releases the water. Okay, so when you releases the water, what happened? H2O, water molecule, it releases. So you will get that compound C will be like this only. Okay, so compound C will be here OH, right? So this side OH and this side CH3, and then this side carbon CHO, aldehyde formation. You'll be getting, you see, CHO, right? So you'll get that CHOs. That means your aldehyde formation will be available. So aldehyde formation comes means now the last one, what do we observe? Last one, which is having sodium borohydride. Sodium borohydride, how do we identify sodium borohydride? Here we just draw the structure over here. So this point, the sodium borohydride converts aldehydes into alcohol. Conversion of aldehyde into alcohol. Now the same thing here, aldehyde. Now here OH, here CH3, and here CHO. So this is aldehyde, which is converted to alcohol due to what it is? Sodium borohydride. So the answer, it is here what it is, here OH, here CH3, here CH2OH. CH2OH, we just draw in this way. How do we draw? Like here OH, CH3, like this we can draw. I hope you got the clarity. Now how do we identify? So each thing we know how to identify. If we know the concept, I think that will be easy to identify the answer. Due to PCC, actually due to PCC, primary alcohol converted to aldehyde, and then equivalent of glycol CH2OH, CH2OH, you will get the cyclic compound, and then Mg, then this OH will be changing. Now which OH will be changing? Due to that Grignard reagent. So Grignard reagent will be changing this point, and then sodium borohydride. Due to that Grignard reagent as well as acid hydrolysis, here also both OH will be there. So both OH releases water, and then you will get aldehyde compound. Aldehyde compound converted to alcohol due to that what it is? Sodium borohydride. The correct option you are getting here CH3, here OH, CH2OH. So option B, you are getting the correct option. Yes, option B is the correct option. Hope you got the clarity about this puzzle and how do we solve this puzzle. Like, hope you got that idea. Come on, let's go to the next question. Also, it is like puzzle question only. Come on, let us check here CH3, CH double bond CH2. Here BH3, THF, and hydrogen peroxide OH minus. You are getting that compound P. And the same way here mercuration oxidation, here also sodium borohydride oxidation, here you are getting R. So P and R, you are getting different product in that undergoing with PCC. So pyridinium chlorochromate, you are getting Q and S. So Q and S, generally you are getting that product that is based on what it is, isomer, relationship between the products Q and S, positional isomer, chain isomer, stereo isomer, functional isomer. So in that we have to identify that which is the correct option. So here three main concept it is hiding over there, actually puzzles, hide and seek question, right? So here what is it here? BH3 THF, it is actually hydroboration oxidation. So the first point for that BH3 and THF, it is actually H2O2 and OH minus. This is actually hydroboration. This is called what it is? Hydroboration. Hydroboration. So hydroboration, what purpose we are using? It is anti-Markovnik's rule. I hope you got that clarity. That's what I said. It is hiding over there. So anti-Markovnik's rule. Okay, so the same way hydroboration, it is used for what it is? Anti-Markovnik's rule. Whereas here mercuration and hydrogen peroxide, here actually BH4, right? Sodium borohydride, it is used for what it is? Anti-Markovnik's rule. Here we are using what it is? Markovnik's rule. Markovnik's rule. So these both are different. That's what three puzzles are hiding over there. So here you are getting anti-Markovnik's rule. That is P, it is anti-Markovnik's rule. You are getting the product, and R, you are getting Markovnik's rule. According to that, you are getting the product. Okay, now what is it? P and Q? Let us check. So P and Q, what it is? Here in that, here CH3, CH double bond CH2, right? So you will get the product anti-Markovnik's rule. So according to that, CH3, CH2, CH2OH, you will be getting, right? So that is another one more. So that is actually what it is? Q or R. So you will get what it is? P and R, right? So this is product P, right? Product P, right? Now we are going to see Markovnik's rule. So CH3, CH double bond CH2. So here Markovnik's rule. So according to that, CH3, CHOH, CH3. So this is Markovnik's rule. Okay, now this is what it is, P and R. So this P and R. So here you will get PCC, right? So here product P, CH3, CH2, CH2OH, right? So this is long chain structure along with the PCC. You will get what it is, CH3, CH2, CH2. Here what CH2 only it will be changing, right? CHO. So that is aldehyde, primary alcohol only converted to aldehyde according to that PCC oxidation. And the same way R, how do we change it? So R, how do we change? CH3, CH2, not CH2, CHOH, right? So here CHOH, CH3, right? So here PCC. So you will get what it is, keto group, because it is a secondary alcohol. PCC convert primary alcohol into aldehyde, secondary alcohol into keto group. Yes, you got it. CH3, C double bond O, CH3. So that means this is aldehyde and this is ketone. So aldehyde and ketone, actually what it is, functional isomer or positional isomer, or what to say, what is that correct option? Positional isomer or functional isomer or chain isomer or stereo isomer? So this is actually aldehyde and ketone are functional isomer. Why? Here's RCHO, here RC double bond OR. So this is aldehyde group and this is keto group. So this is actually a functional isomer. So functional isomer, it is D. Option D is the correct option. I hope you got the clarity. This is anti-Markovnik's rule. This is Markovnik's rule. And this is according to the PCC, you are getting the Q and S. Q and S are, this is actually aldehyde and this is aldehyde and this is ketone. So aldehydes and ketones are functional isomer. I hope you got the clarity. So this is 1 and this is 2 and this is 3. That's what I said. 3 puzzles are hiding over there, hide and seek. I hope you got the complete idea about these questions 11 to 20. And thank you for watching and thanks for your great support. And these questions are like concept based questions related. So you be thorough these concepts, then it will be, you will get the best idea about these points. Come on, let us go to the next question in our next video. And thank you for watching.